Here we've got a simple function machine where we've got an input, and then we've got the function, which is the instructions add 1 and square it, and then we've got the output. So find the output if the input is 5. So if 5 goes in, I add 1 to it to get 6, then I square that to get 36, and then the output must be 36. Again, if I use -2 as the input, -2 goes in, add 1 is -1, square that is 1, and therefore that must be the output. I could also do the same thing with x. So if x goes in and I add 1, I get x add 1. And if I square it, I've got x plus 1 all squared. And that is the output. Now, this is important because in function notation, we'll write that as the function when the input is x, it gives you an output of x plus 1 all squared. And that's what the function notation tells us. It tells us we've got a function, which here is the instructions add 1 and square it. And when the input was x, we got an output of x plus 1 all squared. So here we've got the initial situation there that we just looked at, where the input is x and we get x plus 1 all squared. But this time we've just changed the way we word this question. So if that is true, then find what the output would have been if the input into the function was 5. If that was the case, then we already know the answer to this, but instead of putting x in, I'm just going to be putting in 5. So I'd be doing 5 plus 1 all squared. And just as before, that will give us 36. Again, if I put -2 in instead of x, I just have -2 plus 1 all squared, and that would be 1. So let's have a look at these two options. This time we've got the function of x over here, defined by f of x, and we've also got another function, g of x over here. So when x went into this, it gave an output of 10 minus 4x. And so when x went into this one, the output was x cubed. So instead of putting in x this time, I'm going to put -1 into this one. So we'd have 10 minus 4 times -1. So that would be 10 minus, work out this bit first, that's -4. So 10 minus -4 is 14. So with the second part, we're using this function here because the g tells us that. And then instead of putting x in, we're going to put a half in. So we'd have a half cubed, and a half cubed is just a half times a half times a half, and that's 1/8. This third one is slightly different. So here we've got the function when x went in gave an output of 22, and we've also got here initially the function when x goes in gives an output of 10 minus 4x. So what that tells us is that 10 minus 4x must be equal to 22. So we can form an equation to solve there. 10 minus 4x must equal 22. So now we just need to solve this. So if we take away the 10 from both sides, we get that minus 4x is 12, and therefore x must be -3. Similarly for the next one, this function when x went in gave us -64, but we also knew that when x went in we got x cubed. So we know that x cubed must be equal to -64. So the opposite of cubing something is a cube root, and the cube root of -64 is just -4. Okay, let's have a look at this, except I'm going to move away from numbers and look at inserting other bits of algebra here. So a function of x, when x goes in, gives us 2x plus 1. Now, it might be useful to think of that in terms of output and input again. So if I think initially here, x goes in. So the instructions would have been to times by 2, which would give the 2x, and then add 1 to give the 2x plus 1, and then that will be the output. So with this next one, all this is telling us is instead of the input being x, the input's going to be 2x. So 2x is going to go in, and then we're going to times that by 2 to get 4x, and then we're just going to add 1 to it, and then that will be the output. So f of 2x is 4x plus 1. And you'll notice that all we've done there is, instead of use x, we've substituted in that position the 2x to give two lots of 2x, which is where the 4x has come from. So we'll do that again here. Instead of using x as the input, we're going to use x plus 3. So we'd have two lots of x plus 3. Then we've got that extra 1, and that'll be my expression. So let's just go down and tidy that up a little bit. We'll have two lots of x is 2x, two lots of 3 is 6, plus that extra 1 on the end, so we get 2x plus 7. Okay, this time we've got two lots of f of x. It's important that you can see the difference between this one and this one here. So this is where I'm substituting in the input there for this input here. But this time we've got exactly the same input. So we've just got two lots of this function of x. So f of x is this, and we've got two lots of that whole thing. So that is in essence two lots of everything that is there for the function of x, which is 2x plus 1. You always work out this function of x first, as you'll see in a second. So that would just be 4x plus 2. So a bit more going on in this one, but we're going to work out the function of x first. So here we've got f of 2x plus 5. So instead of the input being x, the input is going to be 2x plus 5. So we're going to have two lots of, this is where the 2x plus 5 is going in, and then I've got the plus 1 on the end. We'll worry about the 3 in a second, and we're just going to sort this out first. Let's tidy it all up. So we've got 4x plus 10 plus the other one on the end. So that's going to be 4x plus 11. And then we've actually got three lots of that as well. So now we can put in the three lots of 4x plus 11. So that will give us 12x plus 33. Okay, final step to introduce quadratics into the situation. So when x goes into the function, x squared plus 4x minus 5 comes out. So instead of putting x in, we're going to put in a half. So we're going to have a half squared plus 4 times a half minus 5. So a half squared is a quarter, so we've got a quarter, 4 times a half is 2, so a quarter plus 2 minus 5. So 2 1/4 minus 5 will be minus 2 3/4. With the next one, instead of putting in x, we're just going to substitute in 2x for the input. So instead of that x, we've got 2x, and we squared that. Make sure you remember to do that, that's an important step. Plus 4 lots of 2x, and then the minus 5. So we'll tidy that up. 2x all squared is 4x squared, plus 4 lots of 2x is 8x minus 5. Again, the next one, instead of the input being x, the input's going to be x plus 1. So we've got x plus 1 all squared plus 4 lots of, and then we've got to put that x in again here. So x plus 1 goes in, minus 5. And then we're going to need to expand this and tidy it up a little bit. So x plus 1 all squared is x plus 1 times x plus 1. We'll tidy this bit up while we're here. 4 lots of that gives us 4x plus 4 minus 5. So double expand these brackets, and we get x squared plus 2x plus 1, and then plus 4x, and then 4 minus 5 gives us minus 1, which will cancel in a second. So we've got x squared 2x and the 4x go together, and the plus 1 minus 1 disappears, so we've got x squared plus 6x. And remove that for a second so we can just do this last one. 3 lots of the function of x. If x was the input, then that's what we got, and that's still the case here, but we've just got 3 lots of that, so we've got 3 lots of this whole thing. And 3 lots of the whole thing will just be 3x squared plus 12x minus 15.